right, so I wanted to go over number 24 on Trig 5. So it says two players stand on a basketball court. The angle of elevation of each foot of each player to the 10-foot high basket are 40 and 50. How far apart are the players from each other? Round to the nearest tenth. So here is your basketball hoop. Right here, it's 10 feet. And you've got player 1 and player 2. And they have an angle of elevation up here and 50 degrees and 40 degrees. Alrighty, so we're assuming that the basketball is completely straight up. Now, the only thing I know here is these two angles in this measurement 10 here. This here is the variable that they're asking me about. They want to know how far apart those two are. Well, chances are I'm going to use right triangle trig because these are two right triangles. So you can really make up any variables you want to make this easier. You could call this x and y, but I think that makes the problem a little bit harder. So I'm going to call this whole length x, and I'm going to call this y. I think that makes the problem a little bit simpler. And we can call this z since we're going to have to solve for it eventually. So we'll call that z. So let's take a look at the big triangle. Let's make an equation for the big triangle. I know my opposite and my adjacent, so I'm going to say the tangent of 40 degrees is my opposite over my, is my opposite, which is 10, over my adjacent, which is x. All right, I can make another equation now for just this little triangle. I can say the tangent of 50 degrees is my opposite, which is 10, over my adjacent, which is y. Well, now I have two equations and two variables, so in theory, I could solve these. So let's go ahead and solve this equation for x. Right, if I cross multiply, I'll have x tan 40 equals 10. And if I divide by tan 40, I'll know what x is. Same thing for here, right? Y tan 50 equals 10. Y equals 10 over tan 50. Well, don't forget, these two things here are just numbers. Tan 40 and tan 50, those are just numbers, right? So if we take a look back at our picture, what is my relationship of z between x and y? Well, I can write an equation that z is going to be this whole thing, which is x, minus this little piece y. So just think about this. If this was 20 and this was 10, I would take 20 minus 10 to get that piece. So z is going to equal the big piece minus this little piece. So I can use that equation now. Z is what I'm trying to solve for. I'm trying to find so I can get some room here. Here we go. So z is what I'm trying to solve for. I'm going to take x, which is 10 over the tangent of 40. And I'm going to subtract y, which is 10 over the tangent of 50. And just put that into my calculator. All right, I can just put that in my calculator. I can say 10 divided by the tangent of 40 minus 10 divided by the tangent of 50 equals 3.5. And that's how far those two are apart from each other. Right here on this diagram, this z now is 3.5 feet, which is what the equation asks you to solve for.